In this episode of Hot Hardware's 2.5 Geeks, the processor core that's right for you might be new. Snapdragons and RISC-V and all kinds of good stuff coming up next. Welcome back, ladies and gentlemen, brothers and sisters. Good to see you again. Well, at least virtually. Dave Altavilla here for Hot Hardware's 2.5 Geeks live stream. We are back yet with more exciting information and deep dive into the tech goodness that has been happening in the last couple of weeks. We missed you last week, but we're back. We were sweating and burning the midnight oil last week. But with me, as always, the ever effervescent Marco Chiappetta. How you doing, buddy?
I'm doing good. I just got off a call with a scammer. I wasted a good 10 minutes of his time. It was great.
Oh my goodness.
Yep.
Oh my goodness. So the tech support scammer, is that it?
It was the "you're being charged by Best Buy" scam. And I wanted to see what he would do. And he took me to a fake Best Buy website and was trying to get me to download something to remote control my PC. And yeah, I had some choice words for him.
So you made him squirm. Good job.
And wasted his time. If I'm there, he can't get somebody else. So good stuff.
Good job. Good job. You're like a vigilante for scammers.
Perfect. Exactly. That's a perfect.
You're like an Avenger, maybe.
Exactly right.
Not quite. Hey, Chris is here. Chris Getting. How you doing, brother?
Hey, I'm good. Pop myself up here. Our new splash screen at the beginning, Marco threw together, has also thrown me off with the flow, but I think we're back on track and going.
Throwing me off too, because in case you haven't noticed, I got no buds in. So I'm going to dip to do that along the way here, hopefully delicately, and you all won't notice. Maybe.
We'll see about that.
Yeah, we'll see about that. But yeah, no, it's been a whirlwind week. We actually had a bit of a derailment, weren't able to make it out to Snapdragon Summit in scenic Hawaii. Really kind of disappointed we missed that show, but we had some boots on the ground there to help and support, from the team. Miriam Joie from our team was covering for us as well. I personally didn't make it, but Miriam was out there. We got some interesting info and tidbits to talk about with respect to Snapdragon 8 Gen 1 and Snapdragon 8CX Gen 3. We'll have all the gens. And we'll talk some other architectures as well. So what's seems to be sort of an inertia, a movement, if you will, in the marketplace for new platform architectures, compute architectures that are really, going mainstream more and more every day. So we'll talk about that. But we should probably first dive into a couple of the interesting tidbits. I'll drop this one in the chat. This was met with all kinds of opinion guaranteed in the comments. Intel CEO, I haven't lost share to AMD. I've given share to AMD, which sounds a little bit like, I don't know, kind of a little tap dance maybe, but there's some nuance and some reasoning behind that. And Marco, I don't know if you want to unpack that a little bit before we just toss that out there and folks can go study up on that one on their own.
Sure. So as is the case with almost everything that you read on the internet, the actual 100% truth is probably somewhere in between Pat's comments and reality. But, Pat Gelsinger is a very aggressive guy, very smart guy. And my interpretation of what he's saying is, yes, we've obviously conceded some share to AMD, but it would not have been quite as drastic had Intel been making perhaps some better decisions and perhaps more investment in manufacturing and solving problems with their manufacturing process so as to have more of the current gen tech out sooner and to have higher quantities of their products available. Like they could not meet demand, so customers just de facto went to the competitor.
Yeah, it's definitely an interesting comment. I think a lot of folks probably took that out of context. You need to read the context, and totally agree with you, by the way. Pat Gelsinger for folks that don't know him, has been in the industry for decades and decades. He was with Intel for many decades before he departed, went to VMware working with EMC, and then came back to Intel more recently and is now the CEO again. Well, not again, but is now the new CEO. He had held previous positions, certainly very close to the architecture. I believe he developed, was it the first 486, Mark? I'm trying to remember what his achievement was.
Yeah,
on the
I think
architecture
I
side.
think his nickname was like Father of the 46 or something like that. But yes, it was the 46.
Yeah, so the guy is an industry heavyweight in a very real sense, and so yeah, he's definitely getting into how we got here in this, or how Intel got there in this position today, where they are today versus AMD and other competitors. And I would say, whatever your opinion is of that comment, I would say that he is hell-bent to never go back there again, right?
You know, I would think so. I'm going to read the exact statement so if people that perhaps haven't read the article understand what he was saying. So his exact
Yeah.
words, this is the quote. I haven't lost share to AMD. I've given share to AMD because I didn't have capacity. So a lot of this is just catch up to our growing market and years of underinvestment. So, Pat just took over and he's basically, I mean, he's not throwing the old guard under the bus, but Intel had problems the last few years. It's no secret. And what he's saying is, had they invested further and had more capacity, they would have had more product to sell, and hence AMD wouldn't have taken so much share. That's 100% true, but it's not really giving AMD the credit they deserve for bringing Ryzen to market and really kicking some serious ass the last couple of years.
Yeah, I'm not
Right.
sure consumer sentiment all just comes down to being able to buy at the volume that it's being produced at. I mean, there are definitely the technical and performance merits that AMD has brought to the table as well. That, to say it's just the supply chain, as we love to bring up time and time again this year. I don't think that's the whole story, but I get what he's saying. But I don't think that's the sole issue. I mean, even if you want to take it from that perspective, the just sheer demand that's taken off in the last 2 years has outstripped what either one of the companies could do on their own anyway. So there's just, that much demand anyway. So there's going to be room in the market regardless of if they had kept up with investment pace or not, I think.
Yeah. Yeah. It's an interesting take for sure. And I think, what we're going to see moving forward from Intel is going to be very different under his leadership. I do like how he can be aggressive like that
For sure.
in the news. It's one thing you don't want from a CEO is to sound like, oh, we're just, we just rolled over and played dead a couple of years ago and making excuses. And I mean, you expect him to put up a strong front. And so I expected nothing less from him in that regard. But yeah, interesting comment, interesting conversation, and it'll certainly be an interesting road ahead as Intel is turning it around here pretty briskly with things like Alder Lake, and then hopefully very soon a forthcoming new discrete GPU architecture that's hopefully going to give some gamers some options in the marketplace versus the red team or the green team. We'll have a blue team GPU now. So let's move on to yet another interesting bit of news that crossed the wire, and then we'll get into the meat. Biden admin pressures Congress to address semiconductor shortage before chip crisis worsens. And there he is, El Presidente, and he's holding up what looks to be a rather, I'd say that's probably maybe an 8-inch wafer. It's holding some jelly bean chips, not some heavy duty chips, I would think, because it's a fairly small wafer versus the 300 millimeter jobbies you see on CPUs. But yeah, interesting, sort of announcement. There is a new proposition afoot called Chips for America, which stands for Creating Helpful Incentives to Produce Semiconductors for America Act. I like the the positioning and the language of bringing chips back home and technology, building our own technology and our own semiconductors here on U.S. soil. I think that's good for the U.S. Any sort of effort in that direction. It now lies languishing in the House of Representatives. It already passed the Senate. This was written by the esteemed Zach Killian from our team. Marco, any thoughts on this? Chips for America. Chips, dips, chains, whips. What's that from? I'm trying to think of that movie.
That's from Weird Science.
Yeah, man, Weird Science. That's good
yeah,
stuff.
That was Kelly LeBrock in Weird Science. Yeah, so the principle I completely agree with. Right now, TSMC is just too important to the entire world to have that. I'm not going to say power, right? But I guess it is power, because if something happens to TSMC, the semiconductors across the world, like anybody that works in semiconductors is in deep trouble. So we do need more leading edge capacity, fab, and it is, I think, considering it critical infrastructure is absolutely true, right? You need chips for basically everything nowadays. And if the government's going to put steps in place to bring some of that leading edge manufacturing to the US, I am all for it. So I think it's a great idea. Do I think any of the politicians working on this have any clue what the hell they're talking about? Not at all. Not even a little bit. I wanted to make a joke so bad with that post. I did it on my personal Facebook, but I didn't put it out on Hot Hardware socials. But yeah, getting the jokes out of the way, and the politics out of the way, it's simply a good idea to put policies in place that will get, and hopefully get, multiple companies to bring leading edge fab process jobs here to the US. Just makes sense.
Yeah, that's an interesting little shot right there. That is a design concept for TI's Texas Instruments new fab in Sherman, Texas. Texas Instruments, that's a name you don't hear very often anymore. Used to be a household name when calculators were big, right? But they are a heavyweight semiconductor manufacturer. Lots of stuff in industrial and automotive and you name it. So yeah, that's a great looking shot right there. The act, which would cost the government $52 billion if funded, would have numerous effects, including 40% income tax credit for qualified semiconductor manufacturing investments through 2024. Also allocates $10 billion to create a federal program that will match state and local incentives for foundry construction. So big tax breaks plus funding and matching. I like it. I like the sound of it. Now, if we can just get out of our own way in government and get it passed and start acting on it, that'd be nice. What do you think, Chris?
Oh, sorry.
Or Mark,
ahead,
I'm
Chris.
sorry. Go ahead. Yeah, if you were going to say.
No, I was going to say it's going to happen. TSMC is investing in Arizona. Intel is investing heavily in multiple fabs. So and I think they pledged 26. I might get that number wrong, but they pledged billions of dollars to build more leading edge fab. So yeah, it's going to happen, but you don't flip a switch and have leading edge fab. So it's going to be many years before that stuff comes here, but in the long run, I think this is going to help everybody. It's going to increase competition. With Intel wants to be essentially a foundry as well for customers. So I think long term this is great. Short term doesn't mean much, but yeah, long term it's definitely a good idea.
Chris, did you have a thought you wanted to impart upon us before we step away from this one?
No, I think Marco touched mostly on what I was going to say. I was going to play off Anthony's comment here that it doesn't think it's going to help the current supply chain shortage, which, yeah, we agree. Because even if they broke ground yesterday, it's going to be, 5-7 years before they're actually producing mature silicon out of those. So, it's not something that's going to help us in the here and now, but definitely long-term looking. There's national security interests as well with the security of how the chips are produced and who's producing them. You can have all the oversight you want internationally, but there's still going to be skepticism and everything else. Plus, you'd imagine it keeps money domestic in the area, which is good for the, our local economy, how it plays into the global economy. Maybe things are, less impactful there, but it certainly does help anything domestic. One thing, that's kind of long been considered an issue with doing this production at this scale domestically is that we don't have the infrastructure built up quite yet. I mean, even as I look up to the Texas Instruments shot here, look around and it's not built around it. So, it's one thing to build the chips, but to get the raw resources in and then, package, deliver, ship out, it does require a lot of infrastructure that currently China and other countries in Southeast Asia in particular do have in place. So there's going to be some catch up in that respect as well. That's going to have to come to fruition for this to be a success.
Sure. I like the idea, though, in general. I think the other thing that you touched upon, Chris, in terms of the economy is putting people to work. And it's going to take a lot of people, bodies to bring this online and then to run it moving forward. Sure, you got robots, tons of robotics in fabs these days, but you need lots of whether it be engineers or factory workers, you name it. And I like that aspect of it as well. We shall see. What's fascinating about this is that we are at a chip crisis, point in history right now, and the demand for tech is so insatiable that we're having trouble meeting it. And it's really sort of it's a hat tip to the industry that we work in. That used to be, the geeks. The geeks are, playing around with computers and things like that. Well, now everybody is digitally connected. Everybody is getting tech savvy, and the demand continues and evolves. And it's a fascinating thing to watch. We're at another inflection point where, our capability in terms of the technology and innovation is, it's going to hockey stick yet again with things like AI and all that good stuff. It's real, and it's creating, demand and new opportunities and new markets. It's a beautiful thing to be in tech these days, right, fellas?
Yeah, man. Two quick things. I want to just pop Paul's comment on. Paul, I still have mine in storage too. And second, one other point, baby. One point that I failed to make, and people need to consider as well. Like I was at the groundbreaking for a Global Foundries fab in upstate New York, and that was really not that long ago. And now that's no longer a leading edge fab. So this requires initial investment and long-term strategy and investment as well to keep this going. I think that's going to happen because it is critical for just so many industries. But just one more quick point I wanted to make before we switch to a different topic.
Yeah, good point. Continuous investment. Totally agreed. It's when you look at what happened with Intel and falling behind the process technology curve, formerly, and I think to this day as well, known as, coined the term Chipzilla, affectionately called Chipzilla. They are now playing catch up because process got away from them. And it takes continuous deep investment, as evidenced by that for sure. Good point. All right. Well, let's dig into the main events. Let's talk about very interesting technologies, new technologies from the folks at Qualcomm. Snapdragon 8 Gen 1. They had a little bit of a rebrand, or a lot of bit of a rebrand, I should say. Qualcomm Snapdragon 8 Gen 1 arrives to supercharge next-gen AI-powered flagships. That right there is a Snapdragon 8 Gen 1 test vehicle. It is not a retail product. That is the hand of Miriam Joie holding that at the Tech Summit. And in beautiful Hawaii on the Big Island in Kona, the Kona area. And some very interesting technology, new core architecture, new ARM core architecture. Cortex X2 is now the prime core, and some significant performance lifts claimed as well. I believe I'd have to look at this specifically, but I want to make sure I get it up to 20% lift in Cairo CPU core performance. Cairo is the Qualcomm brand for their core CPU architecture, which again is Cortex X2 ARM-based plus 3 performance cores and 4 efficiency cores, which are, what are they, A75 ilk? I'd have to look at them specifically. Marco, you may have that on the tip of your tongue, but GPU up to 60% faster when you employ things like Vulkan API in the mix as well, which is, cutting edge graphics engine moving forward. So really just some bold claims, a new architecture, huge lift in AI performance as well. And we'll talk about it. We actually got a chance to benchmark that phone right there. They're talking up to 2x the AI performance over the previous gen. So initial thoughts, Marco, on Snapdragon 8 Gen 1. I'm looking forward to it. And the good news is phones are coming as soon as the end of this month into early Q1, like right around the corner.
So the more I think about it, the more positive I am on Gen 1. So I didn't get a chance to go to Tech Summit either this year, unfortunately. And I assisted with the graphs and putting the benchmark article together. Just to go back to your question before, it's 3 A71s and 4 A51s on the efficiency
A50,
cores in
okay.
addition to
Thank
the
you.
X2. Putting the graphs together, I was like, oh, CPU looks okay. It doesn't look like a huge jump in CPU. But GPU and AI performance are monstrous increases, like huge, off the charts kind of increases. And considering the chips are made at 4 nanometer, and we don't know specifically memory bus width. There was a lot of questions we have after we saw the numbers. Now, it seems they made the GPU massive versus previous gens, right? Because memory bandwidth it's not significantly increased over previous gen. But graphics performance is like right up there with an iPhone 13, beats an iPhone 13 in a couple tests, trails slightly in a couple others. In AI performance, off the charts, crushes everything else, when the frameworks are available to use. CPU performance, it is the fastest single thread Snapdragon to date. It's the fastest multi-thread too. It's just not like this huge generational leap like the GPU and AI engine show. Now, if it turns out you get marginally better CPU perf with hugely better GPU perf, hugely better AI perf with better battery life, killer platform. You're going to see it everywhere.
I would totally agree. I think the average person in terms of CPU throughput for a handset, when you talk about the previous gen Snapdragon 888 class horsepower and from a CPU perspective, I think there's that's a lot of horsepower already for the average mainstream consumer. This is up to 20% faster in CPU, and I think that's probably plenty. This is PC Mark Android for Work 3.0. As you can see, it's faster than Snapdragon 888 in some respects, trails in others. You can see the Snapdragon phone for Snapdragon insiders is actually a little bit faster in this test. But that's a very storage and memory sensitive test. And it's a little bit more bursty, sort of, light duty productivity kind of test, mixed use test. And so I'm not as concerned about that, but it's right up there at the top of the chart.
There's one more nuance too. So there was a performance mode available in the test platform, and the performance mode would have boosted performance slightly. These are in standard mode, the numbers that we published.
Right.
Consumer devices will probably fall somewhere between performance mode on the test device and what you see here, as platforms are more optimized. This is not a high volume product that was destined for retail, so not hugely optimized.
Yeah, that was my next point in this graph specifically, was that you're talking about a device that's it's a prototype device right now, so it's early, things are still maturing, drivers are still maturing. Scroll down a little bit, Chris, until we get to that's the thermals. Keep going. Geekbench, you can see this is kind of telling what we're talking about here. A little boost in single thread throughput, and then sort of top end multi-threaded throughput, but nothing crazy. And then you get into things like gaming and AI. Scroll down a little bit more. There's Antutu. That's an interesting benchmark. Test lots of things like UX and UI as well, user interface kind of metrics, and it's way ahead in this benchmark. So it's hard to tell what the different workloads are between PC Mark and Antutu, but way ahead. Then you get to AI Tutu, which is a benchmark with workloads for object classification and image recognition. So, general machine learning for image recognition and object classification. As you can see there, 2x the performance there. That kind of lift in neural network processing is going to be tangible to the user in a fairly significant way. Whether you think of, different filters, if you're doing crazy stuff, with your camera and your phone, whether it's Snapchat or whatever you're doing. You get into natural language processing, speech to text input, recommendation engines, things like that. When you talk about AI on a phone, I'm going to trigger everybody's phone now, talking to Google and saying, hey, Google, that's where this kind of performance will make a measurable quality of life difference for you.
Is there any word on how this plays into power efficiency? Like, again, performance per watt type metrics, since this is primarily targeted for mobile devices?
Yeah, we haven't done battery life testing on it yet. Obviously, it's a prototype, so they're not going to have us, testing the battery life on a test vehicle.
I just wasn't sure if they had said anything on the specific like chip wattage targets and that kind of thing.
So from a CPU standpoint, they're talking about 30% better performance per watt. Better efficiency, roughly 30% better efficiency. And I think GPU, I'd have to look at the numbers on that. There was another claim on that as well. But this is the other thing to remember is this is fabbed on a 4 nanometer process now. So previous gen Snapdragon, was that 5 nanometer or 7? I believe it was 5. It is a shrink.
Yeah.
It is a slight shrink.
I think they use the die area for GPU too.
Yeah,
so that's
wouldn't surprise me.
Yeah.
Scroll down to the gaming test, Chris. We got a couple of graphics tests. Speedometer, that's an interesting twitchy one. Yeah, there you go, right there. So that's GFX bench. This is a older benchmark, very light workload kind of graphics test. As you can see, it's matching an iPhone 13 Pro, and it's way ahead of everything else Snapdragon. Any previous gen Snapdragon 888. Down one more to Manhattan, Chris, and again off the hook and smoking an iPhone 13 Pro by a significant margin. So over 20%, I would say. I'd just do some quick math on that, but yeah. What do you think, Mark?
I'm speculating that the GPU is much bigger, right? Because for them to qualify that the Vulkan can be, I forget what the performance increase was, but Vulkan was going to show 60 a much larger increase
with Vulkan
up to 60% with Vulkan.
Yep.
If they're doing that with software and they're going to keep that software exclusive to this platform, then it's like, all right, great. You could introduce boosts to the other platforms if you want to update the drivers, assuming that the hardware capability is there in the older GPUs. But if this is from, newer dedicated hardware resources, it's really awesome. And before we talk let me interrupt 1 second. Super off topic. I just got an IM from a friend who's on a conference call on a Zoom with Dell, and there's a really cool logo that he snapped on his screen from the Zoom conference. Look at that nice logo there. Okay, sorry.
Yeah, they got an editor's choice logo on their
that was a best of CES logo.
Oh, all right. There you go. CES 2022 right around the corner. I was going to say, to your point on this graph, you're not talking about Vulkan. This is OpenGL ES 3.0 API. Yeah. So it's legacy. This is legacy game engine, basically, or legacy API for game engines. And so huge gains in legacy says to me, not necessarily custom software, right?
Yeah, I'm just not sure. I don't want to say, oh, they made the GPU twice as big when I'm wrong. I'm not sure. We haven't gotten the questions answered yet. You have
to do a die map shot to see that. Yeah.
Yep.
Scroll down a little bit more, Chris. And then this is what's interesting. Now, Slingshot, that's another one that's a little bit long in the tooth. Let's go down one more to Wildlife. So Wildlife, 3D Mark Wildlife on Android phones uses Vulkan, the Vulkan API. It's a cutting edge graph. And if you saw this benchmark running, the graphics look amazing. Every time, remember back, for a phone. Right. But remember when you've always watched 3D Mark in the past and it's been like, dang, why can't we play a game like that? That looks really good. So yeah, it's a pretty high end benchmark. And then on iPhones, it uses Metal. So it's optimal, cutting edge graphics APIs on both platforms. And here you can see the iPhone 13 iPhone 13 Pro best sit by about 10%. But still, you look at how close it is and how historically, iPhones are at the top of the chart ahead of everything Android. And now,
yeah, I was looking down. The next highest Android handset's the Google Pixel 6 here at 7,200.
Which is surprising that they got that much juice out of the Mali GPU that they chose for Exynos, and then there was a Mali GPU core, I believe, in that SoC, the Tensor SoC for Google. But
which again makes me like, is it an Android thing and software and drivers? Like, I'm just not sure. I have a lot of questions because this was all, we weren't there. Looking at the numbers after the fact, wasn't directly engaged. So like, I have questions, but the numbers look good.
Yeah, numbers look good. Looks promising. It looks promising in a couple of interesting areas. We expect to see a little bit of a lift in CPU. When you hear things like 20% gain, it's like, incremental. Okay, nice. But this is big stuff.
So let's speculate a little more. Go back up to the other 3D Mark chart. So if you look at this one, right, Snapdragon 8 Gen 1, the green bar is physics, right? So it wins in terms of graphics performance and overall score by a lot, even with the lower physics score. So what this makes me think is the GPU is much bigger. It's thermally taking more of the power budget. CPU takes a hit as a result, but the end result is faster gaming and graphics because you don't necessarily need 100% of CPU, So I'm again speculating because I'm not sure, but interesting.
Yeah, most games aren't making physics the limiting bottleneck on performance there.
Yeah. Interesting. Good stuff. Yeah. And as Tim notes, Snapdragon seems to be closing the gap with Apple. We would agree. And Val Air, that is Val Rojas. She says she's excited about the new Gen 1, Snapdragon 8 Gen 1. Val comes up after us this evening, by the way, 7:00 this evening, I believe, Val, you're streaming. She's pulling up her game stream a notch to be closer to when we end our live stream here. You should check her out. She's going to be on Hot Hardware Twitch, and she will be, I don't know what you're streaming tonight, but just toss it in the chat, Val, and we'll plug whatever game you're streaming as well. She's great. She's a lot of fun if you like to watch some game streams. All right. Anything else on this before we move on?
Yeah, I mean, one other really interesting thing with the Snapdragon 8 Gen 1, though, is camera. We probably don't need to spend a ton of time on camera, but huge camera upgrades on this platform that I really want to check out. It's the first, what is it, 18-bit or 14-bit ISP? I don't remember. Dave, do you remember? I got to look it up. Hold on. I have it here. It's 14. An 18-bit ISP for the camera.
Oh, this one. Yeah, I'm sorry. I thought you were going
so this thing can do, it's 3.2 gigapixels per second of processing speed. So you could do, and it is a triple ISP like previous platforms. So you can capture from 3 cameras simultaneously. And it can do 240 12 megapixel images per second, right? Which is kind of nuts. But what this fast speed does, like if you're taking a single shot, it might not seem like you care about all that. But what it does is it allows you to get 18-bit RAW out of the cameras. It also allows for like more advanced computational photography stuff. So like night mode can take a 30-shot composite in the time that it used to take previous gen, I think, to do 5 or something like that. So there's lots of cool stuff coming with the cameras.
Yeah, keep in mind that 12 megapixels is in the realm of 4K, a little higher.
Right.
So that's 240 FPS at 4K type resolutions. It's pretty nice.
Yeah, that's pretty crazy. Yeah.
Now, like you there's only the more you play with a big camera, the more you like. Everyone likes to say, "Oh, smartphones are catching up to DSLRs, et cetera, et cetera." It's not the case in terms of quality, right? It's just not. Even if you have the same megapixels, those tiny sensors, just with all those really tiny, those tiny pixels, they can't gather as much light. But with what you can make up for with computational photography, Qualcomm is really way out in front of everybody.
Right. And if you want to see what's going on with that computational too, use your phone to take a photo with the raw format, and then take a JPEG photo right next to it, and use a raw editor. Take them side by side, and you'll see the raw looks like a mess until you apply very significant processing to it, which they're doing for you when you take the JPEG. So it's the computational stuff is really, really awesome, but you're still fighting physics. So I'd love to see this kind of stuff in a large format sensor camera, but that's a whole other story.
That's what I was going to jump in on, and I don't, we don't have to go down that rabbit hole, but yeah, what amazes me is we don't have this kind of computational photography chops in like this Canon R6 that's looking me in the face right now. It's like what you could do with that kind of horsepower, and you've got the body area to put it in there. I would think. I don't know. There's a reason for it, and we don't know why yet, or maybe you guys do. I don't know why the Canon, or excuse me, the camera companies haven't jumped on board with this kind of tech.
It's been done before. Samsung has launched
they
a
dabbled in it.
Android.
Yeah, I remember that.
I think it was ILC, but it may have been a bridge camera without a removable lens.
Didn't go anywhere. I remember it. Yeah.
Well, so it's I think it's just the companies are really closed and proprietary. So like Olympus, my preferred brand, I have tons of computational photography stuff. I have OM system. So the top selling Micro Four Thirds cameras. So they have, I have a handheld high-res shot modes, which is a composite of up to 16 shots. There's I forget, live bulb and live composite, where you can do light painting. It has AI-based tracking of subjects in one of the bodies. So all of the cameras are moving towards more computational photography, but what you need it for, like with the tiny sensors and the not quite as good glass, is why you need more computational in a phone. So it is going to cross over. You're going to see more of this stuff in big cameras, but you don't need it as much in a bigger camera with a bigger sensor.
Yeah. But interesting, the interesting aspect about this technology for phones specifically is the rate at which we can now capture multiple images and do that compositing, because that's how you get better low light performance. That's how you get better high dynamic range. That's how you get these amazing captures that you're taking this thing out of your pocket. It's the wafer thin, and it's got this little tiny piece of glass, and you snap a picture by poking the glass on the other side of it, and you get this amazing shot. To me, it's impressive to do it on a phone. It's still, there's a obviously people ditched the point and shoot for smartphones for a reason, and DSLRs and mirrorless cameras are now a thing for professionals more so. So it's still impressive what they're doing, and man, they're just upping the game some more.
Yeah, I mean, like if you think about it, I know we have to move on, but like it's really interesting to think about. If you can get a sensor in a camera that reads out fast enough, where let's say you can read out, I don't know, 50 shots in the time it takes for the optical image stabilization, like in the amount of normal handshake. If you can get 50 shots at 50 different exposures, and composite that, your dynamic range is, and your noise is going to go way down. Effective dynamic range goes way up. So that's why phones are getting really good. But
one of these days
we can kill a whole nother hour.
Marco and I will get a guest on here, talk cameras for the whole show at some point.
I've been trying to get Gordon Lang to come on. He said yes initially, and then stopped answering me.
But Gordon's a good guy. He's a good guy. Yeah, definitely. No, it's funny. Occasionally I'll have a new phone in, and I'll snap a shot and throw it up on Facebook, and people be like, "Oh my God, you took that with a phone?" And I'm like, "Yep." Pretty cool stuff. All right, well, let's move on to the next thing that Qualcomm announced, and we'll just dabble in this quickly because we should move on to other architectures as well. But Snapdragon 8CX Gen 3 was unveiled, as well as a new gaming device. That's the gaming device. That's G3X Gen 1 is the processor in that. Did I drop in the wrong comment? Yeah, I did. Okay, I'm sorry. I dropped the wrong.
No, that's the right comment. That's the right link.
That's the right link. Well, I thought we were going to talk about a little bit about the laptop chip, but this is an interesting device, so we'll start this first. Okay. Snapdragon G3X Gen 1. And there you go, in concert with Razer. That is a prototype vehicle, a sort of reference design for a gaming handheld, Android gaming handheld, obviously, co-developed with Razer. I'd have to dig into the specs on it, but it is sporting a Snapdragon processor with built-in 5G, both millimeter wave and sub-6 support, and really just a cool looking device. If you think about the performance offered by high-end smartphones these days, really makes a lot of sense. And there's been in the marketplace, there's been a number of peripheral clip-on kind of setups that have been sold to go for Android gaming or any kind of smartphone gaming, really. But this builds it all into one. So 6.65 inch OLED display, FHD, so 1080p resolution, 120 hertz refresh, HDR display, and all the accoutrements of a handheld gaming device in a Snapdragon powered phone, and or I should say handheld a gaming device, and also in support of things like Xbox Game Pass cloud gaming and Steam and all that good stuff. It should also work with GeForce Now as well, for that matter. So what are your thoughts? We were caught by surprise by this. I will say that.
This one is interesting, right? Regardless of the tech inside, where you think, like, this could really change the game. Now, what I mean by that, if you look at like mobile gaming now, dedicated mobile gaming devices, you have devices like the Switch, etc., previous gen handhelds. Those kind of lock you into that one platform for those games. If this catches on, so this Razer device is initially being touted as a development platform. Razer will probably going to release something very similar to what you see, but the goal is to get people developing games for platforms like this using Android and other platforms. Now, if it becomes that you have multiple companies making devices like this with this common game library, that kind of flips the whole portable gaming market on its head. And then it gets really interesting, right? Because then you have multiple people developing for this one platform, but have potentially multiple devices to play on. That opens a whole potential problems with differences in button layouts and things like that. But in general, you now may have a lot more freedom in what device you play on. So I'm kind of hoping this catches on, and you just have the Android platform becomes just this monstrous gaming platform.
Maybe.
Yeah.
I mean, I think that's hopeful. I think the gaming
It's very
industry,
hopeful.
just with how they kind of manage licensing for a lot of games currently, is a mess. Like, take Destiny that I play, for instance. I play it on PC and I play it on Stadia. But if I buy all the DLC, the season passes and stuff on PC, it doesn't carry with me when I'm playing on Stadia. I just have the base free-to-play game unless I want to shell out extra cash.
It would on GeForce Now, by the way.
On GeForce Now, yes. But,
sorry, go ahead.
There's the beats, and all that.
I got you.
So, that's just an example where, that is one thing that does make Stadia much less attractive to pick up, is that, I don't have the full experience when I go to that unless I want to shell out extra cash. So I don't think that game platforms like the marketplace environment is going to improve anytime soon, whether it's looking at Google Play versus the Apple App Store, or Steam versus the Epic Store, or anything else. I mean, it's going to be a cutthroat world where the consumer loses in more cases than they should for an unfortunate amount of time, I feel.
Potentially. Go ahead, Dave. Sorry.
Yeah, no, I was just going to dive back into the device itself. It's interesting. I wish we had more information on it, honestly, in terms of the processing power on board. We know it's Cairo CPU and Adreno GPU. We don't know what the chip technology is. If it's phone tech, it would stand to reason that it's phone tech, right? We don't know if it's Snapdragon 8 Gen 1 or not officially. Do you you're about to speak, Marco? Go ahead.
Well, yeah, because we got an awesome comment just now from Brian Allen, but I want to bug Chris. Chris, is it possible to go back to the benchmark article that we were in, can you go to the detailed data under PC Mark? I'm going to bring Brian Allen's comment up on the screen. Brian's watching on YouTube right now. He says, Snapdragon 865 is more powerful than the updated 2015 Tegra X1 SoC in the Switch. Switch games run better on Snapdragon than it does on NVIDIA's SoC.
That's an interesting comment. Yeah.
Mhm.
Right. So, but what's really interesting now, if you could go a little lower to the hardware data. So we don't know right here. This is perfect. So we don't know exactly what the configuration is of the G3X Gen 1.
Right.
But if you look at this data, what you see here is at the very, very beginning of a benchmark. Sorry, I got somebody calling me. The chip is running at its top clock speed and immediately drops down. And then the average is somewhere around 1.6. This is in a passively cooled development phone.
Right.
However, that Razer device is actively cooled.
Yeah.
So you now have the potential for these clocks to be way up, right? So if these clocks are staying way up, you have potential for much better CPU and GPU performance.
That's what I was going to get to
for gaming. Yeah.
Right.
So sorry, like that data
all right.
right there will show you there's lots of room, even if the G3X is exactly the same as 8 Gen 1.
That's
it
what
will perform completely different.
2.1 gigahertz max clock on the Gen 1 chip.
It actually can go almost 3. It's going higher than the 2. So
okay, so even higher than is showing on here.
Yeah.
That's a bad graph by PC Mark, but yeah, it peaks at 3 gigahertz. But yeah, that's what I'm wondering. Did Qualcomm have Snapdragon 8 Gen 1 in time to co-develop with Razer for this platform? Seems like it's probably pretty close. I mean, I don't know. It's feasible, but yeah, it's actively cooled. I just dropped a link in the chat. You can see that it's got an intake and an exhaust. So it's actively cooled. So you would think the thermal solution in there is on point. You've got heat pipes, you've got a small fan and a 6,000 milliamp hour battery, by the way. So it's a big honking battery. Yeah, it could be pretty freaking interesting when like you said, when you compare the horsepower that's in something like Nintendo Switch, it should be pretty dang good.
See, what I want, right? My initial pitch is very optimistic, but like what I want on a PC, right? You can update your PC for a decade and still have your Steam library and go back to that old library, play the old games usually, and have the horsepower for the latest games. I want to see that on Android. I want to see this first gen devices usher in a wave of really good games. And then as these devices get more powerful, that Android game library is like PC games where, hey, I can go back and play those old ones and I can play all these new cutting edge games on this new hardware. And that's different than how all of the other portable gaming devices have been.
Well, and if you subscribe to GeForce Now, I mean, there's I believe there's a GeForce Now Android app. There has to be, right? Yeah. So there you go. That's one way to get in there. Of course, you're not
little different.
It's different. Yeah. You're not using the horsepower in the handset. You're rendering from the cloud, but still, it's another vehicle for it.
But it's not necessarily titles developed for that platform. So you always have
I see what you're
controller issues. There's always something inputted, like something
a little weird. Yeah, you're right.
Yeah, and then you don't have to deal with the latency issues of the cloud. GeForce Now is awesome, but there's local gaming is really the ideal way, and I would like to see another platform like the PC for gaming, and that's sort of what they want to do here.
Yeah, and they picked a kick-ass, excuse the terminology, brand, Razer, to do that with. Very well known, huge cachet and impact. And so honestly, the new CEO of Qualcomm, Cristiano Amon, is making some bold moves. I think this is sort of signature of him making some bold moves and bold bets, and I like it. I like step out and do something different.
Yep.
Good stuff. All right, well, let's move on to one more thing. Well, we should mention that also Qualcomm announced the Snapdragon 8CX Gen 3 for Windows on ARM devices. Major performance uplifts to come there as well. And do we have some coverage on that? I know we did.
We did.
Not seeing it. I'm just trying to find the link. We get so many links.
But, yeah, it was in the news.
I'll drop it. I'll drop it in the chat in a minute, but let's move on to something else that was interesting and talk about. Oh, wait a minute. No, that's the wrong link. I didn't capture it right. My bad, folks. Let me get this again. All right.
We'll figure out
Yes.
these newfangled computers eventually.
No, it's the Windows clipboard deceiving me. It certainly wasn't human error. That never happens. HiFive Unmatched, exploring a RISC-V computing experience. So, and then we'll sort of finish up in the last 10 minutes here on this concept now of, new CPU architectures or whatever might be the best CPU architecture for the job. Doesn't have to be x86, doesn't have to be ARM, could be based on an open source instruction set from the RISC-V community. And SiFive is a company that builds processors based on that. And here you are looking at the HiFive SiFive motherboard, and it has a RISC-V based CPU on board. And our good friend Colton Westrate did a little show and tell, set it up and ran it. It has 8 gigs of DDR4 on board, has some flash storage and a bunch of ports, as you can see, the usuals, SD card slots, and booted up some Linux on it. And this is a real little single board PC based on a processor that is designed to support the RISC-V open source instruction set. Wild, totally new, and it is a development platform to get developers in on the action here and working with this technology. Thoughts on this, Marco?
This is really cool, right? So this was one of those things where we got our hands on it. Like the HiFive Unmatched, it's like a $667 development platform. So it's not cheap. I happened to get my hands on one. We sent it over to Colton, and it's like, you know what? Do a build, poke around the Linux build that's available for it, run a couple benchmarks, tell us what you think. So this is not something, this particular product, you're not going to build a desktop PC around it.
No.
It's meant to be put in a desktop PC if you want to develop apps for RISC-V. So in that regard, it's really cool. Plus, it's just interesting to see it in action. So, as it came out of the box, there's 16 gigs on board. You can plug in an M.2 SSD. You can plug in a Wi-Fi card. You can actually plug in AMD. You can plug in any GPU, but they recommend RX 500 series Radeon GPUs. Colton used an RX, I think it was a 270 from an older machine, and it worked fine though. So what you see is like performance just behind a Raspberry Pi. That's kind of a big deal. I know it's not a big deal versus, an Intel Core and a big desktop PC, but you see how much development has happened around the Raspberry Pi, and there's potential in the future for, so I think it's the SiFive U740 is what's on this. SiFive just announced a core that I think is twice as fast, like this 650. I'm going to get the model numbers wrong. And there's even future cores that they've announced that are even faster. So if you end up with, single board computers based on these that are more powerful or as in the same ballpark as the Raspberry Pi, you have lots of cool potential applications. Right. So it was really cool to see this in action. It's a cool development platform.
Functionality first, performance comes later.
Well, and can I just think one more quick thing before I forget, Dave? I'm sorry.
Yeah, go for it.
The very first comment on this article stated that the Ubuntu build runs this chip at 1 gigahertz.
Yeah.
And you can actually run it much faster. I think he mentioned he got it. So he runs his at 1.4, which is a 40% performance boost, which puts it like right there with the Raspberry Pi. So yeah, like there's just a lot of potential here. And with what's happening in the market and with some of ARM's customers a little leery of the potential NVIDIA buyout, there's been a lot of attention on RISC-V. So just interesting developments.
Yeah, no, and that's what I was going to say about the performance side of it. I don't look at that chart and think, oh wow, look at it, it's way down the bottom. The first thing I'm thinking about is, okay, how optimized is the OS and the drivers that are supporting the chip architecture, such that, we're getting the full performance from the chip. My guess is not very well. It's a development vehicle. It's, there was an Ubuntu build that, installed and supports it, but is it heavily optimized? Probably not. It's to get this out into the developer community so that they can develop, whether it be an Ubuntu distro or, other drivers and software support around it to bring out the performance. So my gut says there's more performance on tap than just even just your higher clock speed that you noted, Marco. I think it's untapped potential, but it's interesting. I mean, you're talking about a very classic looking motherboard layout here with something that isn't ARM and isn't x86. It's open source instruction set. It's pretty cool.
Yep. And just quickly, I have the release. The SiFive Performance, this was just announced this week. SiFive Performance P650 processor builds upon the 550, and the 550 is newer than what's in here also. 13 stage out of order pipeline, 40% performance increase, already.
Okay.
So there's lots of action around SiFive and the chips used on, for the RISC-V chips that SiFive is building. There's lots of buzz and action around them right now. So it's going to be really cool to see how this evolves moving forward.
Yeah, it will. And I actually just dropped a link in the chat to point to our Snapdragon 8CX Gen 3 and Snapdragon 7C Gen 3 article coverage, and huge performance claims there for Windows on ARM, 85% faster CPU. I mean, they're making some major claims. This is going to be interesting to get these devices in when they start hitting the market. 60% faster GPU, again, for Snapdragon Windows based PCs. So coming to a laptop near you fairly soon. I'd have to see what's the time frame for that, Marco. Do we know?
I don't remember. It's going to be next year though. I think Q1.
I think it is early 2022, maybe first half 2022. But they just had a test vehicle on hand at Snapdragon Summit. It's a 6-nanometer SoC, built-in 5G connectivity. Really impressive stuff from the folks at Qualcomm. I think will up that performance where they need it in Windows on ARM laptops. But we'll finish off with this notion. It seems now that, again, we're in this inflection point in the market where x86, it doesn't have to be the general purpose architecture du jour. There's lots of alternatives out there. ARM is certainly one of them, and Qualcomm, along with their Nuvia team. This Snapdragon 8 CX Gen 3 isn't the result of it. They may have had a hand in it, but it isn't the first chip launched based on Nuvia design architecture, as far as we know. But there's lots of really tight co-optimization of software and hardware going on now. Apple's M1 architecture is indicative of that. What they've done with M1 and the M1 Pro and the M1 Max is just impressive. We're going to see more of this, right? And it seems like it's getting easier, that having a jump to a new instruction set isn't as big a deal as it used to be. Any thoughts on that? And then
I think it is a big deal to switch instruction sets, but I also think that software is getting more nimble, hardware agnostic. It's going to be more, it's more nimble. It's easier to port over. You have so much performance for most apps. So much performance is untapped that if you have an emulation layer that's highly optimized, it's basically invisible. So using the existing Surface Pro X with Windows 11, even with the previous gen Snapdragon 8CX platform in there, I mean, Microsoft branded it differently, but it was essentially the same chip. It's way better than it was at launch, and you have the 64-bit compatibilities there. Performance is improved. Like, Microsoft did a lot of work on Windows 11 for the ARM platforms. So if Qualcomm's performance claims ring true, where you have 85% faster and which we know that's for multi-threaded. We don't know how much faster single thread it's going to be. 85% faster multi-thread, with similar or better battery life. With, Qualcomm made a lot of announcements in terms of connectivity too, with basically leading edge Wi-Fi and cellular connectivity in a platform that's, let's speculate, Core i5 level, but passively cooled with triple the battery life. A lot of people are going to like that.
Yeah, definitely. Chris, you're a battery life monger. Do you you looking forward to that?
I mean, certainly with anything mobile, yes. So, efficiency is king. The longer I can use a device, the more useful it is. I don't necessarily need it to be the quickest out of the gate in any one task, as long as it can go the distance. So that's what I look
Yeah.
for.
Yeah, good stuff. And really, we're sort of at this, again, I keep using that term, inflection point, but we're at the very beginning of what seems to be a sea change in design. And then I just want to convey this concept, and then we'll leave folks thinking about it, Marco, because we talk with a company by the name of Synopsys, and they do design tools, silicon design tools, what they call EDA design tools for chip engineers. And it used to be that it took a bunch of engineers to do this thing called place and route. You get a design, you map it to silicon, and then you place and route all the circuits and connect them on the silicon design. And then you simulate the heck out of it, and then you send it off to fab, make sure it's been tested and verified, and then send it off to fab and hope for the best. And sometimes you got to spin it a couple of times because there's bugs and all that good stuff. Well, these guys have developed an AI-based place and route tool that you hand it the initial design that's not well optimized, and then the AI just goes off and iterates and knocks it out for you better than a human can, with better silicon area efficiency and power and performance in less time. And then eventually they're going to incorporate verification. So testing the chip before you send it off to expensive multi-million-dollar mask sets and all that good stuff. And then eventually they're going to loop in this is their roadmap, where they're going to loop in software workloads to optimize the hardware design with AI. So think about that and where we're going, and how, design teams are going to get way more nimble, more, fewer engineers required to do some amazing stuff, right? Marco, you've had a little bit of this Kool-Aid, and it sounds pretty wild.
I have swallowed the Synopsys Kool-Aid.
Yeah.
Yes, it's really exciting, because now there's a shortage of engineers, and there's going to remain a shortage of engineers. So if you can take them off, I don't want to say mundane tasks, right? But like place and route and other tasks that an AI can do better. Now those engineers can do, they can think outside the box and do cooler stuff.
Innovate.
Yeah. And that when all of this comes together, it just, when all of that comes together, you can have, there's use cases we haven't thought of yet. And that always happens. Anytime there's these big boosts in compute performance or network connectivity, a new use case is thought of, and it kind of changes how we live our everyday lives. That's going to happen more and more in the years ahead. So I'm really interested, assuming we're all allowed outside of our houses, whatever.
and the AI isn't, like we're not jacked into the matrix at the mercy of the AI, right?
Something like that.
Something like that. Whatever. Well, hey, it's been fun, and it's fascinating stuff. And, we look forward to, the continuing relentless pace of innovation. It is what keeps us excited, and why we love what we do so much, right?
Exactly. Keep me working, baby.
Chris, do you love what you do, Chris?
I do. I just wish I could do more of what I love and less of the mundane stuff. So I certainly get that sentiment.
See, you need Synopsys in your life.
Or the AI or something. Well, at any rate,
someone to figure out where to point the camera, because I kept missing it there.
Well, anyways, it's been a pleasure, fellas. Good catching up with you again here, and thanks everybody for joining us. By the way, we just got through wrapping up our giveaway. Gosh, I got to remember who the winner was. The Falcon Northwest gaming rig was given away. Hang on, let me find it real quick, because this is pretty wild. I want to say Jake Slade, but is it Jake Slade? No. hang on a second. I'm going to drop a link in. Boom. There's the winner. We did have a lucky winner. Randy Slade. It was Randy Slade. And he won this beautiful Falcon Northwest Talon powered by Intel's Core i9 12900K Alder Lake CPU, a GeForce RTX 3090 people, 4 terabyte Seagate Fire CUDA PCI Express SSD, and a beautiful Asus ROG motherboard. There it is.
Yep,
He tweeted it
received
out. Yep. And he is in possession thanks to the folks at Falcon Northwest, Intel, EVGA, Asus, Seasonic. The names go on. Cable Mod for all the awesome, immaculate cabling inside that thing. We will be doing another giveaway soon. It will be probably in time or in conjunction with CES. We may do a holiday giveaway before then. We're not sure, but we usually try and hit it every month. Sometimes it's every other month. Not sure we're going to get a big killer gaming rig like that again, but we're going to get some cool stuff, and we're going to try and stay on the gaming slant. So stay tuned to hothardware.com, where you can find us on the web, twitter.com/hothardware, youtube.com/hothardwarevids. Thumbs up, subscribe, please. Hit that reminder bell so you get notified when we go live with our stream, which we try to hit every Wednesday at 5:30. Doesn't always happen, but Wednesdays at 5:30. Stay tuned in 20 some odd minutes or less for Val Rojas on Hot Hardware Twitch, coming up with some game streaming action. She's lots of fun. You don't want to miss her. And until then, we would have to say thank you so much for stopping by.